No, we've got to be very careful. We've got to, first of all, know how to write out the rules accurately without writing them like this. Distinguish the correct rules from the incorrect rules that look a lot like the correct rules but aren't. Okay? So this is, we'll call this the first property. Log of A times B equals the log of A plus the log of B. So the log of X times A equals the log of X plus the log of 8. Now, this applies to any log, okay? Any log at all. So it could be log base 2, log base 7, log base E, or natural log. The rules apply to any log, as long as it's the same log on both sides. So if like this is a base 2 log instead of an LOG log, the base 2 log of 8 is 3, because 2 to the third equals 8. Okay? So you could further simplify this if it was a base 2. It isn't, so you can't do that. So you want to get adept at following these rules. Since you understand logs and the log graph and the log as an inverse of an exponential, you just got to work this last little detail in, and you can do just about anything you need to do with logs. Okay? Okay, here's another one. Log of five times 2 to the 7th. Well, by the first property, that's the log of 5 plus the log of 2 to the 7th. Anything more you can do with that?
Solve the exponent.
Yeah. The second property applies to this, doesn't it? So, okay? Make sense? So, this is not difficult. It just requires that you remember these rules. Maybe it's easier to remember them if you relate them to the rules of exponents, assuming you know those very well and understand them. But they're inverse to rules of exponents, okay? But if you just remember them and practice them and avoid fallacies, okay, you do okay. Also, I'll say another fallacy.
What product down at the bottom? So he's got the product, so it would change it, and he would still use the multiplication to addition on the log 5 times 7.
You see log of A to the B, you want to raise log of A right to the B power. That doesn't work either, okay? So you want to know exactly how the rules are written, exactly how they apply, and hopefully why they apply, because that helps you make sure you're applying them correctly. I'm sorry, Lena.
Could you, instead of not doing the false, but instead of doing 7 log 2, could you just do log to the 128? That works well?
Log of 128, so 2 to the 7th is 128.
Yeah. Would that work for you?
But that doesn't really get you anywhere.
Okay.
This does. Okay? In other words, log of 128, what's the log of a single number? It's easy to punch into your calculator. But it doesn't simplify this in the way we want to. Okay?
Okay.
You'll see how it works. So you don't want to do that. If you've got a log of something to a power, you always want to do this.
Okay.
Okay? Unless you're trying to go the other way with these. So let's see how that works. So let's think about this. Let's say we have the expression log of x plus 5 log of y.
Log of x.
So can you apply any of the rules
Yeah.
to that expression?
Log of x times y to the fifth